Okay, question 8, the calculus optimization ke le. In the description box uzothola ama-links for other recordings engineer for the question paper. Now question 8 bathi after flying a short distance an insect came to rest on a wall. Thereafter the insect started crawling on the wall. Nayi wall yethu ke, right? And then insect yandiza ke la. Bese ifike iyaresta ke la, right? And then it starts crawling. But thereafter the insect started crawling on the wall. The path of the insect crawled can be described by this equation where h is the height and then t in minutes since the insect started crawling. So the insect crawl all the way up, but nakhona ngeke ilandele straight path yaphezulu, but the height a travel ilelo kanje ile insect is modeled by this equation, right? Now 8.1, at what height above the ground did the insect start to crawl? This is the ground and then this is the wall. I'm just giving you a visual picture la. And then this is the equation used to model ini the height traveled by ilukanji insect yethu. Now sifuna ukwazi ukuthi at what height above the floor did the insect start to crawl. Aso le insect yethu njengoba bengikhomba la, insect yethu ayifiki ihlale la, but instead ihlala at the random point just above the floor. Sifuna ukwazi ukuthi what is the distance from the floor to the point where ilokanji yethu insect yethu ilende khona. So insect yethu nayifika la on the wall, the crawling time is equal to 0, right? So therefore, in other words, last we substitute u0 ku t la ku 8.1 ku t so substitute u0 because of t is 0 ngoba ilokai insect yethu iqala iqeda ukulanda, right? Sifuna ukuthola the distance between the floor and the height above the floor did the insect start to crawl. At t0 the insect is starting to crawl. Asifaka u0 ke lapha ku t, and then lana it's 0 in this bracket le kuzoba u6. 0 minus 6 is negative 6. Lana kuba u0, so it's negative 6. Negative 6 times negative 6 is positive 36, so it's 36 centimeters. So the distance from the floor to where the insect started to crawl is 36 centimeters. 8.2, how many times did the insect reach the floor? I want an insect there tonight, babe. Crawl phezulu, and then it goes. Okay, that's why bengithi ayilandeli a straight path. Phezulu mhlambe iphinde ibuyele phansi. It might fall off the wall, then ilokanje ibuyele kule wall, then it starts crawling up again. Or instead of just going up straight, the insect yenza so. Phezulu ibuyele phansi futhi. Mhlambe iyodla lapha, or mhlambe ibona umngani wayo, then baxoxanyana, then ibuyela phezulu, then it starts crawling up again. So sifuna ukwazi ukuthi ibuyela kayingaki phansi. How many times did the insect reach the floor? Okay, insect yethu nayireacha i-floor, right? It means that the height is equal to 0. So we have to equate this to 0, this equation to 0 now. The height is going to be equal to 0. There's no need to multiply lama brackets now. This is a 0 factor law. 0 equal to 2 yama brackets are multiply nayo. I just do this. T minus 6 equal to 0, or minus t squared plus 3t minus 6 equal to 0. T is equal to 6. So after 6 seconds, insect yethu reach the ground. Or Lana, we also need to find our roots wakhona. You can use the quadratic formula for this one. So a ubani minus 2. So okay, quadratic formula ithi minus b, b ubani 3. So it's 3 la plus minus ngizocala plus square root of b squared 3 squared minus 4 4a ubani a negative 2, c is negative 6 divided by 2a negative 2 equal to, okay, I'm sure ukuthi le ama values wami ngwa insert correctly la. So ithi math error, it means lana for this equation I don't have ama solutions. I can even do negative now. I can even do negative. Okay, I can even do negative lana, still math error. So there are no solutions, or discriminant here too is less than 0. The discriminant is less than 0. So I calculate discriminant. Let's see. The discriminant is 4. The discriminant is equal to 4 b squared. It's b squared minus 4ac. So on. The discriminant is less than 0, so it's b squared 3 squared minus 4 a minus 2, and then c negative 6. This is equal to negative 39. So if the discriminant is less than 0, it means that this doesn't have any solution. So lana we don't have a solution. So the solution is now it's t equal to 6 kuphela. So after 6 minutes, not 6 seconds, man. After 6 minutes, iloganje insect yethu it touches the floor. It goes back to the floor. It reaches the floor. Now 8.3. 8.3, how many times determine the maximum height that the insect reached above the ground. Determine the maximum height that the insect reached above the ground. Okay, we have this equation la. So in this equation, ngidinga the maximum height reached by the insect above the floor. Okay, asenze so sizodinga okay, since ngikhuluma nge-maximum la, ngidinga i-first derivative yami. So the first derivative equal to 0 izonginikeza the maximum value, or the maximum time, the time for the maximum height. Yeah, therefore we need to multiply lama brackets lawa kuqala. So after multiplication ngithola this, and then ht uzoba equal to this. Okay, multiply lama brackets ku simple, guys. This times that times that, uyabhala this times that times that times that, then uyabhala ke uzothola all of this. It's a waste of time explaining that. So asithola ama like terms ke la. So it's negative 2 negative 2t squared no plus 12t squared. Lana it's 10 t squared. Okay, t lao cubed la. It's going to be cubed, and then squared. Okay, singiyabona ke manje. I see now. So lana minus 2t cubed. This and this are my like terms, so it's going to be 15 plus 15t squared. This and this are my like terms. It's 24 minus 24 t plus 36 are gonna like term. So now therefore h prime t is equal to minus 6 t squared plus 30t minus 24. So therefore we equate this to 0 in a trinomial I can either use a quadratic formula or the factoring method for finding ama solutions wamla, but I always go for a factoring method. That's spawn 30 divided by 6 and total 5. So lana it's equal to -6. Okay, ngisebenzisa factoring method, so the t squared must have a positive value. So lana about t squared, that's why I divide that one -6 minus 5t minus 4 plus 4. So therefore my factors wami la about t minus 4 no t minus 1. Therefore t uzoba equal to 4 or t uzoba equal to 1. So between t equal to 1 or t equal to 4, which one is the maximum? Ubani 4. The biggest value ubani 4. Sidinga the maximum height. So therefore isikhathi sethu must be a maximum as well. So therefore height yethu, height at t4 is over equal to, then we go back to the original equation and then substitute manje. Then we substitute. So we need to open bracket 4 minus 6 close bracket -2 and -2t squared. So it's times 4 squared lapa plus this equation. Actually it's the original one, so it's 3 times 4 minus 6 close bracket is equal to 52. So the maximum height they travel insect is 52 centimeters. So this is the last question, 8.3. Thanks for tuning in, thanks for watching. Nangabu enjoy this video, told some value out of this video. Please show support guys by liking, sharing and subscribing nangabu new to this channel. In the description box is my links for other recordings for the question paper. So for now, asibonane on the next video. Bye bye.